So at this stage, we have the floor plan, we've got the walls, doors, openings, and a bed. And we've also turned this into a cluster, so we have all the information here. Now what we need to do is turn this into a 3D model, which we've already kind of done by adding the extrusion. But what we need to do now is add the header. So this is going to be the door height, also the header for the closet, and the header and then the sill for the window. Depending on if you're going to do a sliding glass door or you're going to do a typical window, you would either have a sill or not. So let's get into things we need to do with this script so we can extract the information that's already there and continue on adding onto the 3D model so we can create a module not just in 2D but also in 3D so we can use that in our designs. Basically all the steps that we took for creating this are contained within both of these clusters. So I'm going to go in here and extract a few things. This line segment and this line segment. So I'll go in here, double click, and we have all of these line segments. So I'm just going to select because I know that one of these is the one. So it's this one. So what I'll do is I'll slide it over, tap Alt, so I can copy that one over. And I know that within this other set, I have the other side, which would be this. So I'll take this and I'll tap Alt and make a copy up here. Technically, we can move this wherever we want. So just make sure you have like some kind of organization track or a way that you like to keep things aligned. Okay, so we'll take these two line segments and we need to extract them from the cluster. The way you do that is using these relays, and it's a input that is going to go, when we save this, it will create another output. So let me show you that. We'll take these two line segments, and we also need to extract these other two line segments here, and also these two here. So I'll continue doing this. So as you can see, what I've done is just taken those line segments and I've just made sure that I'm previewing them and that now here I have them copied. So what we're going to do is create a connection between those so we can create the header. So let's create a loft between this line segment and this line segment. And we'll do the same thing for the closet and the same thing for our window. Okay, now what we need to do is with these relays, this is like a wire object here that goes to the outside of a cluster. So what I'll do is I'll take this and copy it. At this stage, now we can take this, disable preview. We don't necessarily have to preview this information. Now we're going to place this here, and this is technically how you can add to your cluster. So down here, we're going to have our headers, and I'll go here to save and close. And all we need to do is here add a surface or a geometry component, and we'll create that 3 times. So that's going to be for this header. This is going to be, so this is going to be door, header, closet header, and window header. So in terms of keeping things organized, we have added some inputs. So I'm going to pull this back a little bit or leave this forward and some of these up. Okay, so now with these, we need to move them up to the door head. So we're going to take these and either move them down here, and we'll do wire display as hidden. This way we don't have wires just overlapping with a bunch of things. We do know that these are our headers and the information we're going to use now. So we can just hide the wires. And now we can start here, moving those to where they're supposed to go. Now let's take these and we're going to move them. So we'll go to a move component and we'll do one at a time. So we'll move the door header using the move component, and we'll go to the motion Z direction. But here's the thing, we need to move it up by a specific amount, and either we using inches or feet, that's going to actually matter. So if, let's say our door head is going to be at 8 feet, then we do 8 times 12 because we are in inches and we need to go from 8 feet to 8 times 12. Therefore, moving this up 8 feet. So this is going to be door head, which is going to be the location of the door. Here's the thing, now to extrude it, we need to figure out what's the overall height and subtract the 8. So now with this, we're going to go to an extrude component. We're going to extrude it in the Z direction. And now let's pick a slider. So let's go 24, just to show you that it would be very difficult, especially if you move the height. So let's go to wall size, wall height, up, which is going to be up here. It's at 12, we'll go 10. So if that's at 8 and that's at 10, so we can go 2 feet, so 24. But if we want to do this correctly, we actually would want to create a mathematical equation. So we know that the height is at 10, and then we subtract. So go to subtraction, 10 minus 8. And now we have here the result, 2. But here's the thing, 2 feet, because the door head and the wall height are in feet. So I actually need to take this and multiply it by 12. So times 12. And you get a component, a multiplication component with B as 12. Now we can plug this into A and use this as our input. So now no matter what height we pick for the wall height, the header is going to calculate the difference between the wall height and the door head and give us the difference there. So let's move this back, get this organized, because this is something, well, the idea with these videos is to show you how to use parametric design, but also how to add on to scripts and how to add on to your own scripts. So you get to do whatever you want with Grasshopper. It's just you need to know how things plug in together so then you can do that for your own designs. So now here we have the header. This is the input. We can double click here and create a relay. And if we want all of our doors and windows to have the same head height, we can just create a relay here, and we can just use the same number for all of them. And so what we need to do is turn this into a bit of a cluster where every time we plug in the header, it's going to create it at that height. So let me show you what I mean. We're going to take all of this and copy it again. So we have this, tap Alt, copy this down here, and bring this one in. Notice that it does that to that one as well, because it does all of the same steps using the same door head. Now we're going to copy it one more time to do it for the window. So now let's go back and look at our design and see when we change all of these parameters, we still have our header and most of our things working together. Notice that even the offset of the wall still updates. Okay, at this point, this is where we would combine all of this together with the walls and create a three-dimensional solid module, and that can be used in 3D rather than in 2D. So all of the stuff that we do in 2D can then be transferred into 3D to create a module. And this way, I am going to show you next how to take that module and array it. So you can create, let's say, a set of bedrooms that are the same design, and they can be arrayed in a bunch of different ways. So I'll be getting into that, but for now, let's focus on finishing up one little bit, which is extruding this bottom part up to create the sill height. So there are different ways to attack this. So let me explain what I want to say. So when doing a window, the dimensions that are critical are going to be the window size. So let's say the window is a specific width. So we have that. We have window size at 8. So it's 8 feet wide. But let's say we want it to be 5 foot tall. Well, you wouldn't extrude this by an amount and then have to calculate in your head like how much is left over. So what we need to do is create the height and subtract it from the window size or the header. So let me show you what I mean. And this is where it takes a little bit of playing around with, because some of these things is just tying your sliders mathematically together. And this is, in my opinion, one of the reasons why we use parametric design is that we can use the data from anywhere and we're not constrained to anything. So with that being said, let's go back to this, which is the sill, and we can extrude it like we said. So we're going to just copy this, and we're going to bring this in again as the input. Notice that we need to bring in a slider, so I'll say 24, so 24-inch tall. But now we need to figure out what's the size of the window. So what we need to do is create a window size. So we'll say 5 feet. We need to multiply it by 12 because it's in inches. So depending on the size of your window and door, if you want them to be in inches or in feet, you would go ahead and do this, which is multiplied by 12. This gives us 60. And now we subtract from the door head. So we do 5 or 8 minus 5, 3 times 12. And the other thing that is critical is egress, right? So if you have a sliding glass door, you don't have to worry, but if you have a window in a bedroom, in terms of egress here in the US, you would want your sill not to be any higher than 3 feet. That way you can egress the bedroom. So here we can pick, whether we want here, take this one. This is going to be the window height. So if your window is 5 feet, then you have a 3-foot sill. And you can also show that using a panel. So let's bring that in here, 3. So every time the door or window height changes, let's say if it's going to be 6 feet, well, this is going to be 2 feet. Now we're going to take all of this and combine it into one. So let's go to a union or solid union. All of these are solid, so closed brep. And the same thing for all of these. So let's plug all of those into the brep input, holding down shift so you can add more than one input. And then when you hover over the output, it'll say 4 different breps in here. So we need to flatten the input. That ensures that, well, they're separate because they're not touching. So technically we actually need to move this and combine it with this. Holding down shift. Let's see if I unflatten it. If we look at the result, it says 3 values. If I flatten it, which means all of them come in one list, we have a closed brep. What that means is that I like to hide the wire display because these are going all over the place, and I like to place this one right out here with a relay. Because the relay doesn't have the hidden wires, so I'll actually go like this and then do a geometry component. And notice that we have something here called a crease, which is when you combine solids, you get this. To remove that, you go to merge all faces, which means if this face is joined together and you have a crease and they're coplanar, it gets rid of it. Show you. And now this becomes what we plug into our geometry. So now I can hide everything here, including the inputs if I want to. And then up here, the existing. Okay. Notice now that we have a closed brep of the entire module. Let's continue on seeing if everything works together. Obviously, at some point it breaks when you have some points that are overlapping with the wall, but all of those can be adjusted as long as you know what you want. So if, let's say, the room is 10 feet, we know that this bed and those nightstands won't work, so we can make it 11 feet. Same thing this way. And depending on what standards you use, you would change these sliders, right? So typical wall size for stud wall 3.5, but if it's sexier 5.5, these are things we can adjust. So it's a little bedroom machine that is going to create a bedroom with all of these details. 3 feet, 2.5. Even if you want a large closet like that, say a walk-in closet, you can have this. Well, for this one, it's mostly, you don't want it to be any less than, minimum 26, 24 inches inside to inside. And then the offset from the wall, the bed. So all of these still work there. We can also turn these into solids or bring in solid blocks and move them to their location in the same way we did with this. So some of the things that we do in 2D can also be done in 3D. And with that, we have the conclusion of our tutorial. Now, I'm going to clean this up. This is going to be on a time lapse. And if you have any questions, let me know. I'll have this script available for you guys to download. And if you have any questions, let me know. Thank you very much for being here, and I hope to see you on the next one.